My favorite feature in the Arduino 101 is the integrated BLE radio. This feature makes it possible to create applications that include high-speed, low-energy consumption serial communications with any device that supports this standard. With BLE, you can build gadgets that can communicate wirelessly for long periods of time, even for years, on a button battery. Most modern computer equipment like laptops, tablets and smartphones already support BLE. The Bluetooth standard specification has provisions for several applications, and through these provisions your gadget can interact with any other device that also implements them. Applications like blood pressure and heart rate monitors, location and navigation, and environmental sensing are some examples. In this lecture, I will discuss some of the basic aspects of Bluetooth and give a demonstration of one that simply toggles an LED on and off. Let's check it out. In this example, I'd like to show you some of the aspects of the Bluetooth low energy BLE peripheral that comes with the Intel Curie microcontroller. Just show you some of the things that you can do with it. Let's pick one of the sketches. For example, let's go to Curie BLE and pick the LED sketch. That's a very simple sketch to get started with. So what happens with this sketch is that first we include the Curie BLE library, and then we create a peripheral device. And in BLE, we've got services that are declared that a device offers to other devices that can connect to it. We use the BLE class to create a service that we call LED, and we give it this ID. Then we give this service characteristics. So a service can have multiple characteristics, and to assign one or more characteristic to a service, we use the BLE unsigned car characteristic class, and there's a few other classes as well that allows us to assign a characteristic. Think of a characteristic as a function or a functionality. It says that the LED service can do this thing here. It can switch on and off. We give it another ID. It's a unique ID that identifies this characteristic, and these are its capabilities. It can read and it can write an unsigned character, so an 8-bit or 1-byte value. So then we set up an LED on pin 13. We set up the service, so the BLE peripheral, which is the peripheral that we created up here. We give it a name, LED. You will see that appearing in a device that will be connecting to it later, that is my phone. We advertise the services that we created. So this is the LED service that is advertised so that external devices can connect to it. And we add the attributes, the LED service attribute. It's this one up here that we created earlier, and the switch characteristic attribute as well. This is the attribute that allows us to send and receive a byte of information at a time. So we set the value of the characteristic to 0, so then we can read that value from the connected device, as I'll show you in a minute. And we start the BLE service. We start the peripheral in the loop. We wait to connect to an external device, and once we do connect, then we start going in a loop and waiting for information to come from the connected device, or we send information to the connected device. Okay, so I will first connect the LED. I'm just going to clean up my breadboard here so that it's not too cluttered for this example. I'll be using the button and the potentiometer in a follow-up example in a minute. So this is a cathode. I'll plug that to ground, and the anode will go to pin 13. The 101 board does have an LED connected to pin 13 is this one here, but it's too small. You might not be able to see it through the video, so I've got the gigantic LED connected instead. Okay. So before I upload the sketch, I will add an instruction for the execution to wait here until serial is connected like that. Okay. So let's upload now. Right, so we've got BLE started on the Arduino 101, and to see what's happening and actually turn the LED on and off, I will use the NRF MCP application. It's one of the Nordic semiconductor applications that allow you to play around with BLE modules. So I've got my app running, and you can see that the first option here has been detected. The scanner is constantly running, and it detected that there is an Arduino that is available nearby. So I can have a look to see what kind of features this BLE service provides. And just bring it a bit closer so you can see. You can see that the LED service is provided in this BLE device. So I will tap on it in order to connect. Now here I've got the, and you can see that on the Arduino side, through the serial monitor, the Arduino was connected to my phone, and I've got central is actually the connected device. It's my phone, and this is its BLE address. Okay, the primary service, you can see that the UUID for the primary service is 1981000, etc., which is the ID that I provided to this service inside the sketch. Drill into the service, and you see that the characteristic that is offered by this service is this one. We didn't give it a name, but we gave it a UUID, and the UUID for that is 198100001, etc., which is the UUID that we gave this service inside the sketch. Those little arrows that you see on the side, these indicate that this service, or sorry, this characteristic can receive and send a byte at a time. We can receive and send data. You can see that the value here is 0, which is the value that we assigned, or that we initialized the characteristic at. So that's what we did in line 43. We set value to 0, and that's what we see here. Now, if we drill down to the sketch, we'll see that at this location here, we check to see if something was written from the remote device, which is my phone, to the Arduino BLE. And if something was written, then we'll grab its value. And if it's anything other than 0, which is a logical false, then it will turn the LED on. So to send a value from the connected device, my phone, to the Arduino, I tap on the out button. Then remember that I'm expected to send out a car, which is a byte or 8 bits, which in hexadecimal are two allowable, two compatible hexadecimal values, or any ones would do. So I'm just going to say 1, 1. That's hexadecimal 1, 1, which is a single byte. So while you're looking at my screen, and in the background there's the LED visible, I'll set this value, and there's the LED on. If I press on the incoming button, you can see that a value was read from the connected device, and the value became 1, 1, which is a value that I sent. That's what was transmitted to the phone from the Arduino. Okay, let's send a 0 to see if we can turn the LED off. So transmit a 0, send, and the LED goes off. So that's a very simple way to interact with BLE devices. And on the Arduino side, you can simply use the library that comes with the Arduino 101. On the phone side, depending on whether you are using an iPhone, iOS, or an Android, or some other type of device, even a computer, a desktop device, then you need to use the libraries that come with those particular platforms in order to implement this type of functionality. But you can experiment with the Nordic semiconductor apps as you are designing the application, at least on the Arduino side. Let's move on to the next lecture, where I'll show you a couple of other BLE-related sample sketches. For example, the heart rate one, where we'll be using a potentiometer to simulate a heartbeat. And I'm also going to do an example that uses a push button.